I'm Chance.
I'm Sarah Catherine.
And welcome to Season 2 of Conservation Connection.
Presented by Last Chance Endeavors.
We're a husband and wife team running a wildlife education nonprofit. It's focused on connecting students to their environment.
Each week, here on Conservation Connection, we do just that by introducing you to the groundbreaking science and conservation work that's happening every day across the globe.
We talk to professionals in the world of conservation science and wildlife management and ask them about their careers,
their current projects,
their wild and crazy stories from the field,
and everything in between.
This episode is a collaboration with Sitka WhaleFest and the Sitka Sound Science Center.
Sitka WhaleFest is a celebration of whales and marine science that happens every November in Sitka, Alaska. It aims to communicate marine science to the ocean-loving public.
Listen in to hear the stories of leading researchers and educators in the Pacific Ocean ecosystem as they share the science and the passion that brought them to Sitka.
Our trip to Sitka was funded in part by Midnight Science Club.
Let's get to the show. Alrighty guys, welcome to another episode of Conservation Connection. We're incredibly excited because we're sitting here in Sitka, Alaska. We're sitting across the table from Mayumi Arimitsu. She is a research ecologist with the U.S. Geological Survey at the Alaska Science Center.
Welcome to the show.
Thanks. Glad to be here.
We're super excited to have you here today. Just to get started, tell us a little bit about your position at the U.S. Geological Survey.
Well, I'm a research ecologist, and I study seabirds and forage fish.
So I'm going to start here with, what is a forage fish?
Okay, so a forage fish is anything really that the marine predators, like predatory fish or seabirds or marine mammals, are eating. These are typically small schooling fish, like you may know about herring, or in Alaska, we have a couple of other species like capelin or sand lance. And these are very energy-rich small fish. People often call them bait fish. And they're really important for marine ecosystems because they pass the energy from the lower food web into the predators. There are lots of kinds of forage fish, more than just the small schooling fish. For example, sometimes the small juvenile sizes of commercially fished species are also important in predator diets, mainly when they're in their first year of life, when they're age 0. You can also have things like that aren't even fish that are kind of grouped in the same category. So that might include krill or small crustaceans that are really important in whale diets. And even squid are sometimes considered forage fish.
So it's a pretty loosely defined term, and it really just refers to small organisms that tend to clump or cluster together and are predated upon, eaten by larger organisms in the food chain.
Exactly.
Right? So they've got a really important role because they're how the energy from the sun makes it into a whale to give it the energy to swim down to Hawaii for its breeding season, right? They're that sort of in-between of the energy coming into the system and eventually ending up into our top predators.
Exactly.
To take a little step back, I feel like birds and fish are kind of specific. We've had a few people on the show talk about sharks and dolphins and everything. What made you interested in and want to study birds and fish specifically?
Well, I always knew that I was interested in marine biology, even growing up as a kid. Of course, at that time, I thought that being a marine biologist meant specifically being a dolphin trainer, which is not what I became. But I was always very interested in biology and sort of the natural world. And when I came to Alaska over 20 years ago for the first time, I was completely fascinated by everything I saw around me. And I happened to be a volunteer on a project that studied seabirds and forage fish. And so I got to go to these colonies and see the birds up close and see them rearing their young and bringing these little fish to their young, and realize how important that part of it was to their whole population and life cycle. So I was hooked kind of immediately when I got here.
It's funny that you say when you were younger, you thought being a marine biologist meant being a dolphin trainer, because that's actually the path that I took before we started this business. But I love that. That's an awesome story. And I mean, For anyone who hasn't been to Alaska, I can tell you, when you come here, you will probably be impacted in some way. Chance and I love it here.
I mean, I'm like you. I've loved the environment my whole life. And I first came to Alaska last year. And from the plane, I was like, I'm ready to move. Like, as we were touching down, I was like, yep, I want to live here. This place is amazing. There's just such the connections between people and the environment are so obvious.
Yeah, it is certainly. And it's great to see. I always love being around people who haven't experienced it as much and they're kind of new to it, because it's just everybody feels that way. I think you're not alone.
There are elements that are just so, it never comes across in your daily life on the mainland or, contiguous US. Whereas here we go walking from like our hotel to where we're recording and see a sea otter or like a stellar sea lion just swimming in the bay. And it's just a totally normal part of life here. And it's mind blowing. It's such a cool experience.
Yeah, I will say that I experience these things every single day, and I'm completely amazed every day. So it's not like it gets old pretty much ever.
That's fantastic.
We are here at WhaleFest. How did you get involved with WhaleFest, and what are you here speaking about this year?
Well, I have been working on forage fish for almost 2 decades, and of course, forage fish are important to all of the predators. So we have work that we started with seabirds and focused on that. But of course, it translates into whales because whales eat the same things as seabirds, which is kind of interesting because they're so much bigger. It's crazy that the whales are actually eating tiny crustaceans and being able to make a living on that. So I started working in Glacier Bay maybe around 1999, and pretty immediately we figured out that we really didn't know very much about forage fish in the park. So the park is really interested in managing their resources and understanding what resources are there. And we pretty soon realized that the forage fish were a really important part to the whale populations as well. And they've, as you know, have a very long time series of a long-term monitoring program for whales, but no long-term monitoring program for the forage fish. So while we were working there, we spent some time looking at whale prey and doing a few different kinds of techniques where you do focal follows and you follow a whale to see where it goes and to see what kind of prey they're attracted to. And
is that like literally following a whale in a boat, or is it like
in a boat? Yeah. So we have they're actually called focal follows, where we're following them in a boat and recording their behavior. So they, they'll be diving, or if they're feeding, they'll do something kind of different. A lot of times they'll start making erratic changes in their headings, and sometimes they'll do neat feeding behaviors. And so we're recording all that. But at the same time, we have hydroacoustics that we're using to measure the fish in the water. And so we're able to see the density and the depth distribution of their prey. So we get a sense of where the whales must be getting their food. Does that answer your question? I think so.
Yeah. I want to take a little bit of an aside and ask, you mentioned hydroacoustics to measure the prey density. So acoustics is sound. Can you explain that to me more? How are you using sound underwater to measure the density of the prey?
Yeah, so this is basically the technology that's used in a regular depth sounder on a boat. And we're transmitting a sound from a transducer that travels at a certain frequency into the water column, and it will bounce off anything that it hits on the way to the bottom. And when it hits the bottom, it will obviously bounce off of that. That's why we know the depth when we're using this kind of technology. So the sound bounces back to the transducer and is read, and the energy that comes back and the time that it took for that sound to bounce back is how we know how strong the target was and where it was in relation to the range from the transducer.
So you make a sound, it bounces off things, and you listen to that echo. And by measuring how strong the echo is, how long it took for the echo to get back, you have a sense of what it passed through or bounced off of between when you put it into the environment and when it came back to you, right?
Exactly.
Cool.
And different organisms have different sound scattering characteristics. So if you for example, hit a jellyfish, it comes back with a different strength than if you hit, say, zooplankton or krill, or certain fish have large air bladders or something that creates a big density change, and that will come back much stronger. So different fish have different scattering characteristics, and that's one of the things that we use to kind of decide how much biomass there is based on their scattering characteristics.
So it's more than just, yep, we hit a fish. It's like, oh, based off of how it sounded, we know that it was likely this group of fish or this type of organism, and how much of it there was, how much that biomass is present, right?
Exactly.
That's awesome.
We also have to verify. So there are a few different techniques to try to sort of separate the types of organisms we're looking at. And one is that we use multiple frequencies. So we have different frequencies, and as long as they're going at the same time together, then you can look at the change between the frequencies to see differences in different kinds of organisms. But we also have to catch some of these organisms too, to find out how large they are and how much they weigh, so that we can really take that backscatter, which is the quantity that we're measuring, and translate it to biomass of fish.
Okay. So you take a small sample of what you just listened to verify exactly what it was.
Exactly.
Cool.
Are you able to study this and see it in real time while y'all are out there?
Yeah, and that's one of the things. So we basically set up transects where we're running a boat along a line, and the boat has a transducer mounted on the bottom. And so we run the hydroacoustics. These are the surveys that we're conducting. And when we see something that, oh, there's a big wad of fish under there, we'll send a net into the water right there and verify the species composition and size and weight.
Very cool. I was kind of thinking, whales are really big. You would kind of think you'd be able to follow them easily. But at the same time, we were on the whale watching tour a couple of days ago. And it's like, you see them at the surface and then they go down. And then you're like,
where are they?
Where are they going to come up?
And they
come up somewhere else completely different. So I was wondering how exactly you follow them. But it sounds like maybe being able to kind of study the fish and see where the fish are, that you can kind of follow them that way.
Well, yes. I mean, okay, so sometimes we definitely, during a focal follow, we can definitely lose the whale. If they're going fast and they're traveling, a lot of times it'll just be like, okay, where'd it go? And you basically are you almost kind of get to know the whale a little bit, and you can kind of predict how fast it's going and what direction it was going. We pay a lot of attention to, we record that kind of stuff, like what's the heading, what's the direction from the boat, how far was it? And then you start timing, and you're like, well, it came up after 5 minutes last time, so it should have traveled maybe that far. Let's move the boat that far and hope that it's still there.
It feels very much like playing battleships.
Yeah.
I think it's going to be in C6.
Exactly. Exactly.
So what's some of the research y'all have been specifically studying in these past couple of years? I know we had the privilege of listening to you yesterday during your talk here at WhaleFest, but I'd love for some of our listeners to get an idea of what that is as well.
My group has been studying a massive seabird die-off that occurred in really the North Pacific during a time when the ocean was very warm. We had a marine heat wave it started kind of in the fall of 2013. You may have heard of it, called the Blob. It was a really big and important event, a very long marine heat wave in this region, something we've never seen before. And there was a very large die-off of common murres, and this is a species that we do study. We have a few colony sites that we work on, and so we're definitely concerned when we start hearing about thousands of birds washing up dead on beaches.
Yeah, what was the scale of this die-off?
It was the largest die-off that has ever been recorded, really anywhere. We believe that between 500,000 to 1.2 million birds were implicated in this. We, along with our, many collaborators and rehabilitation centers all along the West Coast, from California to Alaska, have documented over 62,000 dead and dying MERS from that time period. It was basically from May of 2015 until April of 2016. We found the most birds, about 3/4 of the number of birds were found in Alaska. And we have been studying what happened with that since the day we found out there were thousands of birds washing up on the shore.
So basically there was a marine heat wave. The water temperatures were warmer than usual. And then there was this mass die-off of common mirrors. And so your group has been looking at what the connection is. How did one relate to the other, right? Try to solve that mystery.
Yes. I mean, we also have really been working to document how many birds, where, and the extent of the birds, really document the event itself. But it just so happens that we had also been doing a lot of work on forage fish and the marine ecosystem. And so we had some tools available to us, some data available to try to make the connections to the greater ecosystem. And so I guess what I will say is that in general, we see marine birds die off occasionally. That's something that is not brand new or unheard of. What's different this time is that we had some information about the forage fish. So occasionally marine birds will die off in mass, and a lot of times they, when you find the birds, they're emaciated, they have no fat, they have nothing in their stomach. And we assume that it was a problem with the prey. And that's the end of the story because there's no more story to tell. But in this case, it's really unique because we had, for the first time, a long-term monitoring program, Gulf Watch Alaska. This is one that I'm working with. And we had some information on some changes that were happening in the prey base and in the marine ecosystem in general.
So you happen to be looking in the right place at the right time
yes.
to actually draw some causality out of it.
And to have a few years of data, some years before and some years after, and to really understand that there were changes happening. And that is something that has been kind of unique in this sort of investigation.
I feel like people don't appreciate the role of pure dumb luck in science enough. Like just
sure.
happening to have a long-term monitoring data set on forage fish right before the largest documented die-off. Nobody could have planned that, but because you were working on that, you're able to have a much clearer picture of what happened in the ecosystem from this event.
Exactly. Right.
So at the same time as this die-off and you were studying the fish, does it seem like the fish had gone somewhere else, or were they dying off too? Or
yeah, let's unravel this mystery.
Yeah, what was the relation there?
So it's a complicated story, of course, as most stories can be. And we've really been trying to put the pieces together from disparate sources and working with lots of partners to bring different data together to understand this problem. So I won't say necessarily we have it completely nailed down.
Yeah.
But what we think happened was a major disruption due to this prolonged warming period in the marine ecosystem that really started with, what we saw were abrupt declines in some of the forage fish. For example, there's a species called capelin, which is their populations go up and down, and we think that they're related to cool temperatures.
So
and
it's basically a fish that likes to be in cooler water.
Exactly. And so when they declined in seabird diets, so we do have some long-term information from seabird diets throughout the Gulf of Alaska. And when they declined abruptly, we also saw in some survey data that there was a time when their abundance appeared to be much higher than normal. And then quickly, by 2015, their numbers in surveys dropped off. And so we see seabird diets telling us the same thing as survey information from fishery surveys and on this particular species. We have a couple of other important forage species that appeared to have already been in decline. So sand lance is potentially the most important species for marine predators because they are widespread and they can be very abundant. When they disappear in diets, it's something that we really need to be looking at. And sand lance also had disappeared in the diets of seabirds. There aren't really any survey data for sand lance for us to necessarily compare, but we think the seabird diets are telling us something important in that way. So when we see these two very important species decline, and not only decline, we saw that the larger sizes of both of these species had disappeared. So like a truncation of the older, larger forage fish. That's something that's very interesting and different. We saw other kinds of changes as well, like change in the age structure of spawning populations. And so these things are telling us that larger, more nutrient and energy-rich species are dropping out of the population very unexpectedly. So that was kind of a clue that perhaps there was something going on that was maybe unexpected. And we were looking further into the different kinds of data. For example, we were looking at the zooplankton data, so what the forage fish are eating.
Right, because a lot of times you would think this is a bottom-up issue, right?
We usually think...
Look at the bottom of the food chain and start there and see if there's a problem there.
Exactly. So if we're seeing predators tank, and if we're seeing the forage fish decline, we're usually going to look for changes in the zooplankton that explain that. And what we've seen as we pulled these data together is that the zooplankton actually increased. So these are the food for the forage fish, the copepods, had actually increased during this warm period. And that is something that was very unexpected. It suggests that there was a change that happened at the forage fish level rather than from the bottom of the food chain. So as we unravel this mystery, we're kind of looking at what else could have made that change to the forage fish, and why were those large forage fish going away? Well, we know that large predatory fish are actually much more responsible for consuming forage than the marine birds or the marine mammals put together.
So they eat the biggest chunk of the forage fish.
They eat the biggest chunk of that forage pie. For sure.
And what species are we talking about when you say large predatory fish?
Large predatory fish, I mean, the ones that we're even looking at that we know about aren't all of them. So we know that there are halibut here, we have Pacific cod, we have walleye pollock. All of these fish are cold-blooded, and they are all under the same kind of constraints that happen in warming temperatures. So their metabolism increases with increasing temperature. And what we think probably happened was that their metabolism increased. They needed to eat more during this warm period, and they potentially cropped down those larger forage fish and increased the competition for our seabird predators. So we think that this might be an important part of the story that describes the disruption in the middle trophic level from this marine heat wave.
That's so crazy, because as warm-blooded creatures, we really don't have to think about shifts in metabolism. And I feel like a lot of people, even I, didn't really get metabolism until I was looking at issues in environmental science and stuff like this. But it's basically just the rate at which your body performs chemical reactions, right? So how fast you digest food, how much energy you burn in a given period of time. For us, we're at the same temperature all the time, so that rate doesn't shift. We're in control of that. But for organisms that live in water, their metabolic rate, how fast they burn energy, is controlled by the water. It's controlled by the temperature of that water. And so as the water warms up, those chemical reactions are happening more quickly, because that's how science works, more quickly within the body of the fish, which means that it's hungrier. So across the same amount of time, it has to eat more food in order to stay alive. And so because the water warmed up, all of the predatory fish got really hungry and outcompeted the seabirds.
Yes, and that's our hypothesis.
Right.
That's what we think happened. That metabolic response is something that we need to understand a lot more about, as we know that temperatures are warming in general. But another key part of this story is the fact that the marine heat wave was so long. So we had multiple winters of warmer temperatures, and that piece of it is what could have driven the system to have this prolonged competition effect. In a normal winter, most underwater organisms kind of shut down a little bit. It gets cold, their metabolism slows down in that cold water, and they kind of hunker down for the winter. They don't do a lot of growth. But in this case, they would have had much more need to be swimming around and eating more and maintaining a higher metabolism and even growing during that time. So that's something that's really different than your typical winter here in the northern latitudes.
Yeah. And this marine heat wave started in 2013, did you say?
Yeah, it was called by Nick Bond. It was called the Blob. So he kind of named that, and it stuck.
Yes.
It stuck hard. But it also was compounded by another well-known climate pattern called the El Nino. And that's warming at the equator that happens, maybe every 5 to 7 years. And we can see that it was really during that second year of warming that there was all of a sudden very drastic changes. And we saw it in the predators. We started seeing these birds die off. We started seeing, there was a unusual mortality event of humpback and fin whales in Alaska. And there was also a large decline in some of the commercial fisheries. So we were starting to see problems across the predators. They were really our first indication that something was amiss. It's taken some time to put the rest of the story together.
Yeah. So since this prolonged event happened, have you seen any recovery since the heat wave subsided? And I know we still kind of deal with some heat waves here and there, but have you seen any bounce back from that event a few years ago?
So we've had several years of poor reproduction. We've seen evidence of malnutrition in these birds. And we've seen a continued alarmingly low amount of prey and of reproductive success in these birds. And in 2019 was really the first year that we have seen any kind of reproductive success at the colonies, at least at the ones that I've been monitoring. So we're seeing a little bit of an uptick this year. We did go into another severe marine heat wave this summer, but we're hoping that one is subsiding. So while we're starting to see what looks like a little recovery, we're still cautiously
not out of the woods yet.
Out of the woods.
Yeah. Well, this has been a fantastic story. I kind of want to wrap this up with, as somebody who's pretty well established in marine ecology here in the Pacific Northwest, if you were speaking to like a high school student or an undergraduate who heard this and was really interested, what advice would you give them as they were looking to maybe pursue a career in this field?
I would say that you may be surprised at what you find yourself doing someday, and don't close any doors. Don't say, I'm bad at statistics, so I'm never going to do it. Don't say that you don't really like anthropology because you don't know what it is. Be open to whatever opportunities come your way and get out there and do it. And be ready to learn and find what you love.
That's awesome. And I hope you enjoy the rest of your time here at WhaleFest. And thank you so much for being on the show with us today.
Thank you. It was my pleasure.
Thanks for listening to this episode of Conservation Connection.
If you enjoyed our podcast, go ahead and subscribe to make sure you catch every episode that we post.
We'd love to hear from you. So, if you want to reach out, go to our website, lastchanceendeavors.com/contact, and shoot us an email.
We love questions from our listeners, so if you heard something that you want to know more about, be sure to let us know.
If you've got a minute to spare, leaving a 5-star review on Apple Podcasts will help other conservation-minded people find the show. We'd really appreciate it.
A big thanks to the people working to protect our planet, and a big thanks to you for listening. Don't forget to tune in next week.